Guys, welcome back to Study Learning. Hope you people are doing good. Within these 2 days, I got many requests from you people that sir, we have M4 examinations. Please upload all the units of this deterministic and stochastic statistical methods. So that's why I restarted this DSSM series. So in last video, so we have completed all the topics in the first unit. Now I'm going to start the second unit. Okay, so that is single variable distribution. Here we have to know about what is variable. Okay, so now we will see what is variable and the types of variables which are present in this. So in starting itself I told you that this deterministic and stochastic statistical methods completely deals with the machine learning. So it completely deals with the huge number of data, so we have to perform some operations on the data. Okay, so that's why, so these almost these terms and terminologies are used in your programming languages as well. Okay, so I don't want to discuss those things here. So we'll see what is variable. Okay, variable. So variable is nothing but it's the quantity which changes with the time. Okay, so variable is a quantity, is a quantity which changes or varies. Okay, which changes or varies. So these changes may occur due to the time factors or any other factors. Okay, so these changes may occur due to the time factor or any other factors. Okay, so some of the examples of these variables are, so you might be observed that our height is going to be changed with our age, right? So in the same way, weight. So this is one of the best example for this variable, that is height of the person, with age. So this is one example, and weight also varies, right? So weight of the person. So these are the two examples of the variable, and also we have two types of variables which are available, that is discrete variables and the continuous variables. So types of variables, discrete and continuous. Now we will see what is these discrete variables and what are the continuous variables one by one. So discrete variables. So these discrete variables are the variables which are having the specific value. Okay, so this the discrete variables are the variables are the variables that has distinct or specific value. Okay, so these discrete variables having the distinct or specific values. So while we are performing any random experiments like tossing a head or rolling a dice, so we can predict the what is the outcome, right? So that will comes under these discrete variables. So the values are usually countable, okay, usually countable. And there might be gaps between the data also, okay. So discrete variables have the gap between the possible values. Gaps between the possible values. So examples of these discrete variables are number of people in your classroom, or so if you are producing any products like bulbs, so number of what that defected bulbs in that particular batch will come under these discrete variables, okay. So example for this are, so number of students in your classroom, in your class, and also number of defected bulbs in particular batch. Okay, so these are the two examples of these discrete variables, and then we'll discuss about the continuous variables, okay. Continuous variables. So same, the continuous variables are also variables. It takes any random value in a certain range, okay. So these continuous variables are the variables which takes any value within a range, okay. Let's take an example of, we have the numbers from 1 to 10, so it might take any value from in between that particular range, okay. So this is the continuous variable, and these continuous variables are infinite in nature, okay, so we can't count, okay. So these have infinite number of possible values. So in the discrete variable, we discussed that there might be gaps between the data, right? But here it's not the case. Okay, continuous values or continuous variables do not have any gaps between their data. Okay, continuous variables do not have any gaps in data. Okay, then some of the examples of these continuous variables are height of the individuals, height of individuals, temperature readings. So these are the two examples of these continuous variables, and then we'll discuss about the random variable and what is the discrete random variable and what are the continuous random variables. Okay, now we'll discuss about the random variable. So these concepts and all are very important in your 2 marks. That's why I am stressing more in these particular topics. Okay, so please try to listen carefully. So it might be difficult to understand to you people because this is completely related to machine learning. Not a problem. I'll be here for you. I'll clarify. So if you have any doubts, please comment down your in comment section. I'll clarify your doubts as well. Okay. So random variable. Just now I told that so we are performing random experiments like tossing a coin and rolling the dice, right? So it might gives the random values. We are not for example, if I want 6 in the sense at that time 6 is not going to come, right? So likewise, so a real variable x whose value x whose value is determined by the random experiment. Okay, determined by the random experiment. So these random variables are going to be obtained from the random experiments. Okay, so random variables again are of two types, which is discrete random variable and the continuous random variable. First half of your second unit deals with these discrete random variables, and second half of your second unit deals with the continuous random variable. And also one thing I'm going to suggest you people that so within these 2 days of period, it's difficult to what go through the entire syllabus. So one of my suggestion which I was followed in my engineering is, so I'm going to split the syllabus into two. Okay, so first half I'm going to be thorough of it, and the remaining half I'll see what like headings likewise. Okay, so that's what I'm going to suggest you. So if it is the good, so you can follow, or else you can complete the entire syllabus. Okay, so random variables are of two types, that is discrete random variable and continuous random variable. Now we'll discuss what are the discrete random variables and what are the continuous random variables. Okay, same here also. So we are going to find out the random variable x. Okay, so a random variable x which can takes only finite number of distinct values or finite number of discrete values. Okay, so a variable x which takes finite number of discrete values in an interval. Okay, values in an interval of any random experiment. Okay, random experiment. So here it takes finite number of discrete values. Okay, so these are termed as the discrete random variables. So examples of these discrete random variables are tossing a coin and rolling a dice. Okay, tossing coin, rolling dice. Then we'll see what are the continuous random variables. So hope you people are clear with this discrete random variable. Now we'll see the continuous random variables. So here the variable x can take the values in a continuous manner. Okay, which can take the values continuously. Continuously are termed as the continuous random variables. Okay, so examples of these continuous random variables are the temperature measurements, time, height, age. Okay, temperature, time, height, age. So these are some of the examples of this continuous random variables. Hope you people are clear with what is variable and what are the discrete and random discrete and continuous variables, and what is the random experiments or any random values variables. So in that we discussed about the continuous random variable and the discrete random variable. So now we will discuss the probability functions of the discrete random variable. Okay, so just now I told you this first half of your second unit is completely deals with the discrete random variables. Now we'll see the probability function of the discrete random variable. Okay, discrete random variable. Okay, so for a discrete random variable x, the real value function p of x, so which is going to be for a discrete random variable x, the real value function real value function p of x, that is it is termed as p of x equals to, so p of capital X equals to x. Okay, so this is what the probability function for the discrete random variable, and we have some properties of this. Okay, so properties. So this p of x value is always greater than or equals to 0. Okay, so p of x is always greater than or equals to 0. Okay, then sum of the probability values is 1. Okay, so this is one of the property of this probability what discrete random variable probability function. So summation of, so I values range, what the values of probability values ranges from 1 to n, right? So for that, summation of I equals to 1 to n, so p of xi. Okay, so probability of all the sum of probabilities of the experiment is going to be equals to 1. Okay, then so this p of x value is lies in between 0 and 1. Okay, so p of x value always lies between 0 and 1. Then so you might having a doubt that so whether we get any negative values in this discrete random variables, in a sense, no, absolutely no. So p of x cannot be a negative value. Okay, so p of x cannot be a negative value. Okay, so first probability function of the discrete random variable is p of x, that is p of capital X equals to x. So it has some properties, 4 properties, that is p of x value is always greater than or equals to 0, and it might some of the probabilities of this probability function is going to be 1, and then p of x always lies in between 0 and 1. So p of x value cannot be negative. Okay, so this is the introduction of the probability function of the random variables. Now we'll see the probability distribution function. So probability distribution function. So probability distribution function f of x equals to, so p of capital X is less than or equals to small x. Okay, so this is the probability distribution function. So it also have some properties. So this function value also lies in between 0 and 1. Okay, so first one is 0 is less than or equals to, so this probability distribution function is less than or equals to 1. Okay, so it lies in between 0 and 1. Okay, so f of minus infinity, so if any negative values, in the sense it's going to be 0. Then if any positive infinite values, okay, so if any positive infinite values, so it might be 1 or infinity. Okay, so it value may be 1 or infinity. So these are the three properties of this probability distribution function. So the probability distribution function f of x is equals to p of capital X is less than or equals to small x. So properties of this is it lies in between the 0 and 1. So if any the negative infinite value, in the sense it's gonna be 0, and if any positive infinite value, in the sense it might be 1 or any infinite value. Okay, so these are the properties of the probability distribution function. Then we will see the cumulative distribution function of discrete random variable. Cumulative distributive function of a random variable. So this cumulative distribution function is also similar to the previously discussed function. So it is gonna be f of x equals to f of capital X is greater than or equals to small x. Okay, so this is the cumulative distribution function of a discrete random variable. And then we have the probability density function. Probability density function. So this probability density function f of x is determined by d by dx, that is derivative. Okay, so derivative of the f of x. So this probability density function is going to be obtained by the cumulative distribution function, that is a derivative of the cumulative distributive function. So this is the probability density function. Then we have some expectations like mean, variance and standard deviation. How we are going to find out the mean and the standard variation of discrete random variables we will discuss. Okay, so they might be asked that what is the expectation value of the particular data. So expectation, first we will see the expectation. So is this expectation value, that is e of x. Okay, it's going to be computed as sum of I equals to 1 to n, okay, pi into xi. So you just make a note that what is going to be expectation and what is mean, what is the variance, these things and all. We'll discuss the problems in the corresponding video, next videos, no worries. Then we have some properties of these expectations as well. So these some properties of these expectations are e of x plus any constant value. Okay, so if it is e of x plus any constant, in the sense we have to find out the expected value of the x and we are going to add that particular constant. Okay, so this is one of the property of this expectation. And then we have one more property, that is e of any two random variables. Okay, x plus or minus y. Okay, so this is going to be expectation of x plus or minus expectation of y. So if they are given positive, in the sense you can take the positive value. If they are given the negative, in the sense you can take the negative value as well. Okay, so these are the two properties, and we have some more properties. If it is here the variable is going to be what, added, but what if it is going to be multiplied? Okay, that is e of x into k. So in this situation you just multiply that variable with the expected value of the x. Okay, so this is how we are going to find out the thing. And then we have one more property, that is variable multiplied with the expected. So here the same thing. So if we combine these two properties, that is, let me take an example of f ax plus something b, it might be any constant. Okay, so at this situation you have to multiply the a value with the expected value of x So either it may be plus or minus. Okay, so you can take, and then you are going to add this b value. So this is one more property of this. What if two variables are the either it may be addition or subtraction, in the sense this is a formula. If they are multiplied, okay, so expected value of x into y, so this is going to be find out as expected value of x into expected value of y. Okay, this is how we are going to compute. And then what if it is in the fraction? Okay, so if it is in the fraction, expected value of 1 by x is going to be expected value of 1 by expected value of x. Okay, so this is how we are going to compute whenever they are given any variables or any two data. Okay, so this is what the expectation value. Hope you people are clear with this. Then we will see how we are going to find out the mean. Okay, mean. Now we will see the mean. So basically mean is nothing but sum of the observations by number of observations, right? But in this case, here it's going to be computed as same. Almost the expected value and the mean value are similar. Okay, so mean is going to be denoted by this symbol mu. Mean mu is going to be p of x. It's going to be what? Pi into xi, same thing. Summation of I equals to 1 to n pi into xi. So this is how we are going to compute the mean. Okay, then we will see what is variance. Okay, variance. So variance of any particular data which they are going to be given is computed as variance of x equals to f of x square minus f of x whole square. Okay, so this is how we are going to compute. So it is going to be just now we have seen the mean, right? So f of x is nothing but f of x or p of x, it's going to be mean, right? So f of x square minus mu square. Okay, this is what the variance is. Hope you people are clear with this. Then we will see the standard deviation. Okay, standard deviation. So this standard deviation is nothing but the square root of the variance. Okay, standard deviation is going to be square root of the variance. Okay, so that is variance. Here we come here we have computed that x square minus mu square, so it might be the expected value as well. Okay, so here also some properties are there for this okay, so those properties and all are not that much important, so you must be clear with these concepts. So before going to the problems, so you just go through all the things which we have discussed in this particular video. So from next video onwards, I am going to start the problem. Yeah.